All right. So the car class over here is this car lab is the one we're going to be working through here. And I want to kind of basically take this step by step, because it's, I think, going to be very important to understand how to take a class from the UML over here. This is what you're going to have to do for the final PA. So I want you to have an example of this recorded, excuse me, and make sure that you understand how to do this and take this and translate a UML diagram over to actual Java code. So we're going to be creating two classes here. We're going to be creating car tester and car.java. Only car tester.java is going to have a main. So car.java is going to be a completely mainless class. So we've done a few of these in there and done some driver kind of things. And this one's just going to have a tester. And you could even create a car test where you create JUnit tests around this too. So that's another thing you could do. So we're going to add the 3 instance variables here. This is a pretty simple lab. I'm not grading this lab, so don't worry about a grade. If you want to submit it to Canvas just to make sure that you're able to get through things, I'm not even looking at style in the Canvas grader. It's just looking to make sure that you're doing the things inside of the class correctly. But if you want to do that, I've put the assignment up in Canvas or in AutoLab so that you can actually check your own class at the end of the day here. So let's go create this. It's public class car. We're going to create 3 attributes here. So we've got attributes. And we're going to create 3 of them. And the minus sign means it's going to be a private attribute. We're going to have private string make, private int year, private double speed. So those are the 3 attributes that we see over here inside of our car class. And so we've added those in. We're going to code the constructor. So I'm going to call this here. I like to usually put an extra comment in there. You don't need to. You could just say car constructor here. Inside of your java.comments at param, and we're not gonna, I don't know if we're gonna put a parameter in here, so let's just go ahead and leave that way. Then we'll come into here and we'll go public go ahead and open up this file over here. All right. And we want to have public car. And we are going to code the constructor. This should utilize these items here. So we're going to have a string M, a int Y, and then we're going to use those inside of the constructor here. So we're going to do this, and we're going to have this guy set with those, and then we're going to create this car inside the constructor. This should initialize the make and year fields using the arguments to the constructor, and the speed should be initialized to 0. Okay, so we're going to create these things here, and we're going to say this dot make equals M. So that's the M that we're getting in from the string that's being passed in there. And we're going to set this dot make. So the make of this car is going to get set to M. To say this dot year equals Y. Those are the 2 parameters that were being passed in here. So, or arguments to this item. So we're going to take those, and then we're going to take in here, we're going to say this dot speed equals 0.0. That's what we're always going to start a new car at 0 miles an hour, which is a good idea since you don't want to drive it off the assembly line at 50 million miles an hour. So once we create the car, it's going 0 miles an hour. That's the constructor for this piece. Let's go ahead and save this as car2. I'm going to call this just because I've already got a car in here. Save anyway. Yep. And then let's go into here and we will call this next piece here. We're going to code the constructor, code the toString method. So we're going to go create a toString method here, and we want this public string, which is what this toString is going to return over here. It's going to return a type string, and we're going to say toString, and this is the explicit toString, so that we have something this is doing, and we want to do something here with this string format. So let's go string return string. Actually, I think we're gonna do return string equals string dot format, and then we'll do all of these things that we want to do with this. So I think that's going to need to go to the next line. So we'll go ahead and do that now. We wanted to follow our style here. Let's go ahead and make sure this is checking style. Yeah, I think that's fine, except for we don't have our Java docs. I'm not going to bother with Java docs because we're not checking it here. And also I want to get this done and then move on to some other things for today. So let's go ahead and do that. And we're going to return string. So we're formatting this, and we're going to say a blank %D, a 1975 or whatever the car year is, and then we're going to say the make that is going %.1f miles per hour. So that's what we're going to do when we do our toString. All right. So we've got the toString created. Code to the constructor, code to the toString method here. We want to partially test your partially completed car by adding a main to the car tester. So we're going to create a car tester. Let's go ahead and file new Java. And we'll say public class car tester. And in here, we're going to want to copy this code into here and run this. All right. So if we create the car tester here, let's go ahead and let us take this code. I'm actually going to go ahead and take this. And I'm actually going to copy this over to this other car class here, and I'll save it. That way we've got it. Okay. All right. Got this saved here, and then we're going to create the car tester. Let's go ahead and compile this here. We've got a car class. Oh, we need something else over here, semicolon. All right, so we've compiled the car, and now we're going to compile this car tester, and we're going to run it. And it's going to say a 1997 Ford that is going 0 miles an hour, a 2014 Toyota that is going 0.0 miles an hour. So we've created 2 cars in this car tester, and they're working fine. So the remaining methods we need to do, we need to create some other methods in here for the other guys that are the getters and then the setters here. So the 3 getter methods should return the value of the appropriate instance variable. So we're going to go look at these 3 getters: get, make, get speed, get year. So let's go ahead and do that real quick. Public string get make, return this dot make. These are simple getter statements, just one line statements here you can do these in. And we'll go get speed, and this is a double. This dot speed. And the last one here is an int. I'm gonna go public int get year. And this is going to be this dot year. Just three simple getters here that we're going to fill out. And then we want to do the accelerate method here. So this is a setter here that is going to set something here. So we want to go public void, because the return type is void here, accelerate. And inside of the accelerate method, should increase the current speed of the car by 5 miles an hour. It should not be possible to increase the speed beyond 150 miles per hour. So we want to say if this dot speed plus 5.0 is greater than 150, then we want this dot speed to equal 150. Else, if this dot speed plus else, and this one we can just do an else. This dot speed equals this dot speed. Actually, we can do a plus equals here, plus equals 5.0. All right. So that's pretty much it as far as this method. So we're just adding 5 miles an hour to the speed if it is within those constraints. So we can't go over 150 because that's how fast the car can go. That's the max speed of the car. We could also add in here a variable that is a overall, let's do that too, constant here, that is this 150. So if we added in this max speed equals 150, then let's go ahead and use this max speed in case we change this, so that we would be able to change the number in one spot and not have to change it anywhere else if we're going to be using that 150 as our max speed. So we could set this, and then what if we design next year a car that we could make at 170 miles an hour? Then we wouldn't have to change that but one place, and it would affect all of the cars that we were creating properly. All right. So we've gotten that. How will you test that this is working? How many times do you need to call accelerate before the upper speed limit is reached? We could test that with a loop. Let's go ahead and do some testing though. Let's go ahead and car one for int I equals 0, I less than. So if we're doing 5, we're going to need to do this 30 times here. So let's go. Just to be sure, and then also to know that we're not able to go past that number. So we'll do that 5 just to see what happens there. And then we're going to go into here and we will say we want to do car1.accelerate. And if we do that, then we can do this, and we can do over here system out.println. And we can go here and do car1.getSpeed. And we'll print that out. All right, let's do this. Let's do that. Let's do that. And then let's run this. So we get up to here, we're starting at 0 because we started our car 1 at 0. We're going 5, 10, 15, all the way up to 145. Then we hit the upper ceiling of 150, and we keep hitting that ceiling here 5 more times here. So that's what we're showing here. And so that seems to work, and our accelerate method has been created successfully. So we need to do another one that is another setter, that is the break method. So we're going to want to do one here. Let's go ahead and submit this, though, to AutoLab. I'm going to go ahead and jump into here and submit this into AutoLab to see. I want to submit my car.java. Let's see how many points I'm getting. I should not get the 10, so I'm getting 0 here because your submission did not compile. What did I do to this guy now? Oh, I started another type in here for this. All right, let's save that, compile that, and then let's submit this and see what we're getting. I think we should get like 7 points or something. So it doesn't have the break method in here, so it's taking off points for the break method. So we won't even get anything there. Let's go ahead and put in the break method then. Break. Let's see if we do anything here, if it's just going to, I think that's a void method here. Where are we doing that? Break void, yeah. So what if we just have the break method, but don't do anything with it? Let's compile that. Is that compiling? Yep. Let's go ahead and submit this again and see if it will actually be okay with it, even if it doesn't work, that we now at least have all our methods. Maybe it'll give me some actual points here. Yes, okay, so we've got 9 points here because we did everything, but we didn't pass the one test for the break here. So now we need to finish out this break method here. And the same way we were adding 5 miles an hour, the break is going to allow us to subtract 5 miles an hour into here. So our piece here says the break method should decrease the current speed by 5. It should not be possible for the speed to drop below 0. Okay, so we want to come into here and we want to say, something like this dot speed minus equals 5.0. That's going to drop us 5 miles an hour. But if we started at 0 and we went to -5, we're going to need to correct that if we have incorrectly set this. So we would want to say if this dot speed is less than 0.0, then we're going to want to do this dot speed equals 0.0 and reset or recalibrate the speed here before we finally are done this method. So that's what we'll do in here. We could also do some different analysis of checking that before we even do the setting of it. So this is one way of doing it, is just to go ahead and set it. The other thing we could do is if this dot speed minus 5.0 is less than 0, then this dot speed equals 0. And then we could have else here and go this dot speed minus equals 5.0. This would also work here. So if we were doing a check here, we would want to make sure that this was going to work. This would work, or that other piece of code that we just had in there would also work. So just 2 different ways of doing it. This is probably the better way to do it because we're never setting it to an invalid value. Instead of setting it to an invalid value, then correcting that invalid value. That's kind of not the way you should think about it. This would be a much more proper way to think about that. So, all right, let's go ahead and do this and compile that. And then let's go over to here and submit this and see if we've got this piece of code corrected. I think this should actually work now. All right. 10 points. So that is now working as designed and as we've specified it. So this is now complete. You can use the viewer canvas here in order to see what these things are doing here. Let's go ahead and do that inside the car tester here. We'll do this and we'll take a look at what this is doing. Let's go ahead and work through it. And if we look at this, we can drag items onto the canvas. Let's go ahead and drag car 1, car 2 into here. This way we can see what the values of car 1 and car 2 are and what's going on with them as we go through the execution. So if we were to step in here and keep stepping through, we're returning into here and we're coming into here and we're going into here and adding 5 miles an hour. We're continuing to add 5 and we're going to get through all of that business until we get to that 150. And then at that point, we get to that 150, then it's going to cap at the 150 point there. And we're done. And then it deletes our objects once the execution is done. But there you can kind of see how that canvas works and what it looks like and what the objects look like inside of there. That can be helpful to visualize what these cars are going to look like. So, all right. So let's take a look now. Since we've looked at that car class and created it now, let's look at some of the methods that are in there. So our method definition here, we're going to review some of that terminology. This is the method definition, the full method and all of its pieces from the curly brace to the opening curly brace to the closing curly brace. That's the definition of our method. Here we have the method body. That's everything inside the braces for the method. Then we have the method header, which is just this front line here without the braces. That's the method header. So it's just the public void accelerate double amount there. Then we have what's called the method signature, which is just the name of the method and its parameters. So those are the kind of terminology pieces to describe methods. So we've got these different pieces, just a reminder of those pieces. All right, let's take a look at this person class here. So if we create a person class that has a name here, this is a private attribute name. We're going to say public person, and we're going to pass it a string called name, and then we're going to set name equal to name. This could also be this dot name equals name. And that's why I like to use and overuse that word this, because otherwise you've got a statement like this that says name equals name. That's correct, but it's really kind of obtuse and kind of hard to read in my opinion. And I like to go this dot name equals name, because that would allow you to think about this object that you're currently, this person you're working with now, their name is going to equal, the name attribute is going to be set to this name parameter that we passed in as an argument here. So that's what we want to do here. So then we're going to say public string get name, and that's going to return the name. This is a very simple class here. So we've got this over here. Will this compile? Yes, we can compile this if we had this in a main section here. And this is going to create a new person named Bob. What will be printed? Bob, because we're going to do the get name of Bob here. The name parameter shadows the name field here. So we're okay here. Next thing we've got here is if we have this person, Bob, and we're going to system out print line Bob.toString. What's going to get printed here is going to be the memory address of the person, Bob, because we don't have a toString method in here yet that we've written, an explicit toString. So it's going to go to the default toString method. Any class that you create without a toString is going to automatically print the memory location of the object for that toString. So that's the default toString, as we call it. So that's what's being compared there. Versus if we create an explicit toString, that's going to be overloaded, and we're going to run that instead of the default toString. So that's the piece that you need to make sure you understand that. So even if you don't write a toString class, there's going to be a toString that exists, and it will do some things that you may not want it to do when you're running your class. So what if we create an explicit toString here? It's going to say person named and then the name attribute from here. So will this compile? Yes. What's going to be printed? Person named Bob, because this is going to be print lining Bob. And if we create Bob and just do this Bob here, that's going to call automatically the toString method that is associated with this object Bob. And this object Bob is a type person. So it's going to go to the person class and it's going to find the toString and it's going to print it over here. That's the default that is going to happen when you print a string or version of an object and you pass this person object to the print line. It's going to try and print the toString of that. And it's going to return that string over here and it's going to print that string that says person named Bob. So make sure you understand this piece, that if you pass the object to a print line statement, that it's going to automatically call the toString. Whether or not that toString has anything that it does is up to you and how you've written your class. All right. So the next piece here we've got this Bob1 equals new person Bob, Bob2 equals new person Bob. System out print line Bob1 equal Bob2. Will this compile? Yes. What's going to be printed? False. And the reason this is going to give a false is because Bob1 is not pointing to the same object as Bob2. And that's what the default equals does, is it's going to compare the memory addresses of Bob1 and Bob2 and see if they're equal. In this case, we have two objects, Bob1 up here and Bob2 down here. And those are going to point to two different items here. So we've got two different items in here that we've got Bob1 and Bob2. They're not pointing to the same object, so it's not going to print that way. This is another distinction, the default .equals method. So if you go here and you say Bob1 equals Bob2, we're going to come into here and it's going to run and compile. It's going to also say false because, again, this is still calling the default .equals and we haven't created a .equals method. So if we create a .equals method down here, public Boolean equals and person other, we say we're going to return name equals other get name and SSN equal other get SSN if we added an SSN here. So both of those values have to be the same. So if we create this piece of code that says Bob1 and their SSN is 1, we've got Bob2 and their SSN is 1, and we've got Bob3 and their name is Bob and their SSN is 3. And then we've got Bob4 equals Bob2. So what we're going to get here is we're going to see if Bob1 equals Bob2. So these are going to be equal using the equals method here. So that is going to be true here. Then we're going to get Bob1 equals Bob3. These are going to not be equal, and it's going to give us a false. We're going to get Bob1 equals Bob4, and we're going to get Bob4 is 2. So those are pointing to the same object. So yes, that's going to be true as well. Then over here, Bob1 equals Bob3, again, equal Bob3, and that's going to be a false because they're not pointing to the same object. And then we're going to get Bob1 equals Bob4, and we're equal Bob4. That should be a false because it's not pointing to the same object. But then Bob2 equal Bob4 is going to be true because they're pointing to the same object, because we set this thing up here where they are pointing to the same thing. So that is the sequence of output that we're going to get in this case. So remember that you need to provide a toString and equals method, and that should be the essential part of developing any class in Java that you're trying to develop. If you have no toString method, it's going to complicate testing. And if you have no equals method, it's going to lead to sneaky weird bugs or complications. The broken dot equals equal for memory location is going to be provided by default. So you're going to get some weird operations if you try and do a dot equals against objects that you haven't written an explicit equals. All right. So go through this and take a look at this one as well to make sure you're understanding this piece. We talked about immutable and mutable objects last time. String is an immutable type because you can only take a substring and create a new string from it or make a copy of a string. When you're editing a string, you're really not editing it. You're creating a new string and pointing the string variable to another string object. So, and we need to be careful that our methods don't accidentally modify mutable objects that are passed as arguments. So this is why we don't tend to edit arguments when we're passing them into a method. All right. I'm going to go ahead and move into the next section here, which is 10.1 through 10.3, the homework sections here. So I'm going to go ahead and set this up in Eclipse for the first one, and then I'll set it up in JGrasp for the second, and then you should have a pretty good idea what's going on there for the third one, and you can set that up yourself for the soccer game. All right, I'm going to go ahead and launch this workspace. I'm going to set this one up, file, new Java project. I'm going to call this one homework 10. Inside of there, we'll use project folder as root for source and class files, and we'll hit finish here. Okay, no source files exist in there. That's fine. We'll go right click here, new Java class. And we want to call this class, what is it that we're calling this one? We're calling this one a parking lot class here. All right. So we're going to define that parking lot class. Inside of here, we'll go ahead and create a main in there just because we want to be able to use that to test. We'll do generate comments in here and we'll hit finish. Default package. So we're actually wanting to delete that and use the default package here as well. Then we'll click finish. All right. So we've got this parking lot class in here. And that version will have 4-15-21. Actually, let's go 4-19-21 to remind us that that's when it's due. I have followed JMU honor code. And then let's go ahead and get into here and we'll do the main here. Args not used. And we'll come into here. All right. So in this parking lot class, let's take a look at this. Let's actually put this 50-50 here. I don't know how well that'll work because this is kind of to the side. All right, here we go. So we're going to be using the point and the rectangle class in a lot of the operations we're going to be using here. So we're going to be using other classes. So in here, we're going to need to import those classes here. So in this particular one for the one over here, the parking lot, we're going to need to import the rectangle class. So we'll add this import java.auth.rectangle here. All right, we'll save that. This is not being used is what it's saying, and that's fine. All right, so we're going to define a class named parking lot with the following method. So we want this method here inside the parking lot. And so here we've got search. Search is lot for a parking space. Lot is an array of parking spaces. And this is a car is a rectangle to fit in a space. All right. And we're going to return the integer that is going to represent the leftover space when parked. All right. 0. All right. So this is going to set us up for being able to actually do some testing here. Let's go ahead and go into here, and I'm going to go ahead and have this loaded. Let's load that. Yes. All right. So let's go ahead and create a test case here that we are going to create. We'll go create a JUnit test case. We're going to file new JUnit test case. We're going to call this parking lot test. We'll use the new Jupyter test here. And then we want to generate comments. Class under test is parking lot. Next. And we want to test the search method here. And we'll click finish. We want to add the JUnit 5 library to the build path. That's fine. And that should help us out here. So now we've got this piece here. Instead of this particular import and set of imports, we'll go ahead and just do the import non-static. We'll say org.junit.assert. And org.junit.test. So those two imports should be fine like that. And then we're also going to want to import the rectangle class, java.auth.rectangle. All right. So we need that in there. And then over here, let's go ahead and create this parking lot test. And we'll create all of this and that version 4-19-21. I followed JMU honor code. Let's go ahead and delete that. And then we're going to save this. And we'll do a public class parking lot here. And then we're going to have a test here for test search. This is going to test the search method. And we're going to want to do several different things in here. So we're going to want to say Boolean parked equals false. Then we're going to want to go test the first space in an array. And let's go ahead and set up an array here, rectangle array. My lot equals, and we're going to go new rectangle 10 by 10 space here. We're going to say new rectangle 12 by 12. And we'll go to the next line and create one that is a new rectangle of 14 by 14. All right. Oh, this is this way. Yeah. All right. This needs to be like that. So now we're creating this array of rectangles. All right. All right. So we've got 3 parking spaces in here. One's 10 by 10, one's 12 by 12, and one's 14 by 14. So each of these spaces has a 0 zero axis. And so this 10 by 10 is over here. And then we're going to see if we can park the car into this space here. We're going to need to set up a car here too. So we're going to create a car, test car. And we're going to say rectangle car equals new rectangle 6 by 6, because that's what we have in the sample that we were given here. So this 6 by 6 car in a 10 by 10 space, what we're doing is this will get each space is going to have a XY coordinate system. So you're going to have a 0, 0 out to 10, 10 for the first space. That second space will have 0, 0 to 12, 12 as its space. The third one will be 0, 0 to 14, 14. So you're going to be going through that. This 6 by 6 car will fit in any of these spaces, but we know that we want to park in the first space that it can fit in. So we're going to check that over here, and we're going to say assert equals, and we're going to test the first space here. That's what we're testing, and we're going to come into here and we're going to go 64 as the leftover space in this, and make sure that this is the right thing here. And that's the amount of leftover space based on a 100 square foot space and a 36 square foot car. Then if you subtract those two numbers, you're going to get the right number of leftover space, which is 64 square feet. So that's the expected square footage that's left over. Then we're going to call this parking lot.search, and we're going to pass it my lot and the car. And off of that, we should be able to get a check of this. Let's see what we've got in here. Assert equals, why is that? Question marks, 64. Equals parking lot dot search my car or my lot and the car, and we've got both of those defined. Then in order to also check this, we're going to go parked equals car dot get x equal to, and we also need to, yeah, and equal to, and car dot get y equal to. So this is going to also check if we position the car. So the X and Y coordinate of the car rectangle needs to be positioned at 2, 2 so that it is centered within that 10 by 10 space. So in order to have 2 feet around the car entirely, we need to make sure that we're positioning this car at 2, 2 in order to, over here, this is 1, 2, 1, 2 is where the left corner of this car is parked within the 0, 0 space of the parking space. So that's what we're trying to check in there. So make sure you're understanding that is how that is being checked. All right. Then over here, we're going to reset car.x and car.y equals 0. And then we can go do some other pieces. So and we're going to check this parked here. Let's go parked. Assert true. Location is 2, 2. And we're going to go parked. So we're going to check that variable too and see if we've actually set that correctly there. And if we have, then we're going to go ahead and reset the variable or the location of the car, and then we're going to check for parking in other spaces here. So now if we do another test in here, we can do check for third space, and we can create an array over here that is a second lot. This lot will be a 2x2 lot, or a, sorry, 6, 6, 7, 7, and 10, 10. So we know we can't fit the car into a 6, 6 space because it's the same size as the car. The 7, 7 doesn't give us enough outside space. And then this 10, 10 is the reasonable space again. So we're going to want to do our same assertions here. And create another Boolean here to check this business. We'll want to check this piece again over here. So second location is 2, 2, and parked 2 is that check. Then we're going to say car.x equals 0 and car.y equals 0. So that's setting the car x and the y to 0 again. Make sure this is correct. I keep getting the error there. What is the error here? I think this is all correct, so I'm not sure why it's giving me such problems here. That's okay though. This, I will provide this file here, this parking lot test.java inside of Canvas. So I have a version of this that's out in Canvas that you should be able to download in the files section under files, homework 10. This one will be available, and also the stub for this guy here as well. So you can download those to be able to use to test your pieces. So that's 10.1. As far as how to set up tests and how to create cars and spaces to do the testing. Just wanted to show you that. And then in order to run the test, you would run the test over here and run this and see if you are able to run. It's not going to, it's not going to pass because obviously we haven't written anything inside of here yet. So this test is going to fail pretty miserably. So, all right. So this should be able to run, and you should be able to test this and see if there are any issues with this particular class. If you were to actually return 64 here, you would actually get and run this. Let's go ahead and do that. You'd pass parts of this test, but you're still failing the other parts with the location of the car. So if we did something here where we just manually faked this out and we said car.x equals 2, car.y equals 2, and we fake this out, we can kind of get this test to pass parts of the test, more parts of the test, but we'd still not be fully testing that. So your job is to finish this piece here and actually return the proper leftover area of the car in the space, and also make sure the car is moved to the proper space 2, 2 for this particular, if it's a 10 by 10 space, that it's going to 2, 2, or whatever that space, you're going to have to calculate that. All right. So 10.2, what you're trying to do in here is you've got a yard and you've got this tree planter you're trying to create. Let's go ahead, and I'm going to go ahead and get out of Eclipse now. And I'll go into here, and we'll go into, let's close the viewer here and get into the browser here. And we want to create a homework 10. I think we've got one now. Yes, let's go into here. Let's create a class in here called Tree Planter. Let me go pull these from Canvas. So inside of the Canvas course, I want to make sure we have these available. So I'm going to come into here, and I'm going into our course here, and inside of files, let me go ahead and make sure homework 10, I'm going to publish this and make that available. Homework 10 over here, we've got the tree planter over here, and this, I want to grab this code. This, I think, is a 4-spaced code, so you may need to change this out to 3 spaces to have it pass check style. But this is going to be the pieces that you want to grab here. Let's go ahead and grab this, though, and let's go ahead and put this in. That's not going to be an issue because I'm going to have to redo this anyway. All right. Come into here. We're going to do some stubs here. All right, so this is tree planter. We're doing this here. We've got 2 methods we're writing for the tree planter. We've got, and then let's grab this too. I'm going to go ahead and over here, I need to do this rainbow document here to create this. This is going to create the tree planter test. I'm going to go ahead and copy this though, and grab all of this and paste it into here. Again, I may need to do some formatting with it to get it to format correctly here. Do my 2 imports here for the point class and the rectangle class. Then I'm doing my imports here for the JUnit testing classes. Then I've got my actual test class here that I'm setting up. And I'll set up my test here. This test is going to be on the next line here. And I'm going to set up several points and a trees array. And I'm going to test things for a single tree in the yard. And then I'm going to test multiple trees in the yard here too. And then I've also got another test method for optimize here. I want to test that as well. For the optimize method, I'll have a yard, and I'm going to test optimizing where to put the tree in the yard. I don't know why this copied and pasted so poorly, but it did. So let's go ahead and do that. All right. All right. I want to probably get this into here too. Yep. If you download this, this should have a little bit less issues with all of this business. So let's go ahead and compile this though. And then let's run the test. and this test is going to fail. We're going to have a positive test for this optimized because whatever we're doing with our optimized test is working because we're returning a point in here, and it's actually returning a point. So it's not going to have a problem with that. So let's take a look at what this is asking us to do. So we've got this tree planter class, and we've got two methods in here. We've got this distance, so it's going to compute the distance from here to all the other trees in the yard. So if we've got 4 or 5 trees in the yard, we're going to need to measure the distance, and this is using your kind of point-to-point kind of comparison of how far away from the tree it is. And if there's if one of the other trees is already planted here, then we can't plant that there. And we're going to want to check that from here to all the other trees and return a sum total. So we want to find the full distance between here, the point we're looking at, and all the other tree points inside of the yard. So we're going to have points that are in different spots in this yard, and then we're going to have this point we're looking at trying to plant the tree. And we want to see if here is what the distance between all of these points is. Then over here in optimize, we need to determine the next place to place a tree, given the yard boundaries and the location of other trees. We're going to return the first location that's farthest away from the other trees. So the distance is going to matter. So we're going to want to go through the yard, dimensions of the yard. So if it's a 100 by 100 yard, we're going to want to go through that entire yard, and we're going to say what point is the furthest distance. So we're going to need to use that method that we wrote first, that distance method, and find the furthest point away so that we can space out these trees. So that's what we want to do there, and then we're going to return that point that is the furthest away point from the other trees. So that's what we want to do in here. AutoLab is going to reject words like int, long, integer, or long. So you must also not use the equal operator. You're going to have to use this by checking dot equals within the point object, and use some of the items inside of here that you can use for decision making inside the loop. The get location, get x, set location, these kind of things, equals method in here. So these kind of items are the things you're going to need to use to determine where to plant that tree. This third one here for soccer, it's got two methods, the inbounds and the pass. What we're basically doing is you're going to have a player rectangle that's going to have a place right here. You're going to pass the ball from a particular location over to the player. So this polygon ball is going to be a polygon of different sizes, and you're going to want to make sure all the points inside this polygon are either in bounds inside of our boundary here, and our boundaries are from 0 to 0 to 12,000, 8,000. So you're going to have to make sure that all the points inside the polygon fit within that 0, 0 to 12,000, 8,000. That's the first check. Then the second one is if you're going to pass to this rectangle player, what is the way to get to from this polygon's location, XY location, over to that player? Can you make it to that player without going out of bounds? So these are the pieces. And again, you'll need to check and may want to leverage this inbounds method when you're doing this pass method. So that is the pieces there. I'm going to go ahead and stop the share here, and then I'll end class here. If you have any questions, I'm going to go ahead and log out of this meeting and then start up the office hours meeting.